All right, so we're just going to do a quick, very quick review of some of these terms, and then we're going to use them as we move forward back into the world of derivatives. We're going to talk about mins and maxes, points of inflection, and we're going to use derivatives to help us find it. So for vocabulary words, we can have, when we talk about mins or maxes, we can have a relative min or a max, or we can have an absolute min or a max. So I'm just going to abbreviate that, and I'm using my finger instead of my fancy thing, so that's why it's so slow. So absolute, actually I'll write the whole thing. I'll abbreviate in a minute. And those are two different types of mins or maxes. A relative min or a max is also called a local min or a max, and it is just in a very short little region of your graph, in that little subset region or domain restriction. That is the highest or lowest point, where an absolute max is globally the entire graph. If you look at the whole graph, the entire domain of the graph, that is the absolute highest or lowest point on it at all. I think I mentioned this before. Maxima is the plural of a maximum. And again, I'm just going to write max. And a minima is the plural of a minimum. So if you want to talk about more than one maximum, you'd say maxima. And same down here, extrema is a generic term referring to both mins and maxes. So if you're talking about extrema, it's looking at both possibly max or mins, or both. So it could be either one of them. And up here, sometimes for a max, if you have more than one max, instead of saying maxima, you could probably say maxes, which is kind of the plural of max. And I'm just gonna, I guess I'll put an ES on here, but I might not put an ES on that. And if I pluralize minimum more casually, I might say mins. Again, an abbreviation or a shortened version of max and min. Maxes and mins, maxima, minima. So again, an absolute max, so if I'm just talking about a max, is the highest point in the entire graph. So over the entire span of values, it is the highest point, if you will. So not all graphs have them, but some do, and we're going to look at that in a minute. And it is also the absolute max is the ruler of the world. So again, it is the grandest, highest peak of all. So there is no point higher than an absolute max. And if your graph continues up to the right, so quickly like this thing just keeps going up to the right forever, it has no absolute max because it doesn't ever end. It continually goes up to infinity. And so we're switching just kind of, again, if it were absolute min, it would be the lowest point in the entire graph. Now if I am talking about a relative min, it is just the lowest point in a limited portion of the graph, if you will. So that's just in a portion of the graph. So not the entire graph, just a portion of it. And it is the bottom of a valley, if you will. So, and I'm going to abbreviate, so a portion of graph, I'm just going to say a portion of G, and it is the bottom of a valley. So again, if I just look quickly at the graph below this, which looks like a parabola, this is a min. It's actually, in this case, it's an absolute min because it is the lowest point in the entire graph, but it could also be considered a relative min if I just looked in this region here. And again, if I was talking about a relative max, it would be a highest point in a portion of the graph. So what I would like you to do is there, again, so I'm just going to, before you look at these questions, this would be a relative max and this would be a relative min, because they are not the overall highest point or lowest point in the whole graph. If I look at this graph, it looks like each of these is the same height. So they would all be the highest point this graph ever gets. So they would all be absolute maxes. These look like the lowest point this graph ever gets, so they'd be absolute mins. This graph has no absolute min because it goes down to negative infinity, but it has an absolute max here, a relative min here, and a relative max here. So what I would like you to do is you have whatever here, 2, 3, 6, 9 graphs, and you have 9 explanations talking about whether they're absolute or relative and how many there are. And so one of these graphs matches each of these descriptions. So if you could take a few minutes to try to match those up, that would be fantastic. Okay, my assumption is you have taken a look at those 9 graphs and 9 descriptions and have written a letter for each one of them. I'm now going to show you the answers, so please take a look and see how you did compared to what I wrote down here. And if you have any questions on these, please look back and see if you can understand why these were the choices. And if you have any questions, it is something we should definitely chat about in class, next class. So mark down any questions you have, and I think that's it. See, not too bad of a video.